Hello everyone, I hope you are doing great. In this tutorial video we want to talk about simulation of solar cell, especially solar cell with composite material. For example, CZTSSe solar cell, CIGSSe solar cell, and maybe some perovskite material, that composite material with different ratios. In this tutorial video I want to show you how can you define different compositions. In this example we want to investigate the CZTSSe solar cell, but I try to teach you basically to define other materials also, and let us start it. Okay, as you can for the initial data you can search my name in internet and go to my research gate. In my research gate you can go to publications. In the publications I've inputted the data for my papers. I have 2 or 3 papers that about the composition material CZTSSe and also CIGSSe, and just you can download the data files and input into your SCAPS. Also you can do this file for the console simulation also, and we will talk about it. Okay, you can see my publications in the one of the publication with the name of improving, let me show you, improving the efficiency of CZTSSe solar cell by engineering the lattice defects in absorber layer. In this paper we work on the defect properties of CZTSSe, that is the basic reason for and also main reason for low efficiency of the solar cell. We simulated the bandgap graded and composition material of absorber layer. Here is CZTSSe. We did the simulations with 2 different approaches. Finite difference, that means using SCAPS, and finite element method, which means use console multiphysics, and also free FEM software that I'll talk in the other tutorial about it. Okay, when you go to this link and you can see the proof version of paper, which means the paper before publication. You can go the supplementary resources. I provided the data here. Let me go to the data. You can see 2 files, SCAPS file, CZTSSe solar energy.rar and solar energy simulation FEM. That is not concern of mine here, and I download this file. Also this is not necessary to join in ResearchGate. Also you can download it without any login or any account. I go to open folder. Okay, just do click right on it, go to WinRAR, extract to SCAPS file. You must open it. after open this file, it's better to, let me show you. You must put this data in the SCAPS directory, and let me choose this file, azo.abs. The file with extension of abs, I copy two of them and I paste it into SCAPS directory. You must go to local disk C, program files x86, and go to SCAPS 3306. Go to absorption and just click right and paste two files. After that, I go to GRD file. GRD file, which means the grading file. Let me copy the GRD file. Okay, just show more options and copy them. Go to SCAPS directory and then go to grading and paste these files here. Okay. Also, you can see the SCAPS files that can be opened with SCAPS software. You can go to open with, and you must go to look for another apps. Previously I add the shortcut of SCAPS to my desktop. I click on it and I use open it. You can see the icon of the SCAPS will show here. Okay, as you can see, the a small panel of SCAPS. This is because of the graphics of this system. We can change it. I can use a quit. I can click right on the software, go to properties. In the compatibility, you can use the change DPI, or maybe use the run for Windows 8. Let me OK on it and open it. Oh, excuse me. It's better we change the DPI in some system. It's better use changing the DPI. I go to compatibility and I go to change the DPI and I use OK. It seems it doesn't work. Let me try it again. I click right on it and go to properties, go to compatibility, and maybe use the system for override DPI. I use apply and maybe I uncheck this option. Okay, and now you can see the medium size of SCAPS icon and software, and in some systems it's better to change the DPI, and also in some systems it's better use the compatibility for Windows 8. It depends on your operation system that you've installed in your computer or in your laptops. Okay, let me continue. As I told you, you must just open this file with SCAPS software. As you can see, the all of settings are available here, and there is no need to change any files, because when you double click on the SCAPS file, if the initial files were not applicable in the directory, the SCAPS show the errors notifications. That means you must input the initial data for that. Here, let me show you. Okay, as you can see here, we have an absorber layer CZTSSe, that we have a file that I've inputted in the first, and then you can see there is no error here, and just the data can be shown here. Okay, also the absorption file, for example azo.abs, is readable by this software, and just you can click on OK, you can click on calculate single shot, and you can see the IV curve results, and this is the IV curve. You can compare it with experimental that I've provided in my paper. You can cite my paper, you can ask any question that you want to know. Okay, let me talk about the composition of material. By the formula that I write here for you, you can see the CZTSSe consists of CZTS and CZTSe material. When we have a y equal to 0, it so let me show you in my paper. You can let me go back, then I can download this file as PDF. You can download it freely, and excuse me, let me I hope the PDF. Okay, you can also see the preview of the PDF here. As you can see, the all of parameters can be varied and can be changed by the material composition ratio. Here you can see the band gap of the CZTSSe, the Y, which means when the Y is 0, you have CZTSe, as I wrote here for you. When we have I equal to 1, it means you have CZTS, and the CZTS term is remain. Okay, and which means when you have y is 0, it means you have CZTSe, and y is equal to 1, it means you have CZTS. Okay, and here from the file you can see the composition, and also you can use it from a file. You can use from uniform pure A, which means you have a compact material without any impurification, and also you can use uniform pure B or uniform Y between 0 and 1, or linear, or parabolic 2, logarithmic, which means it depends on your measurement in experiments, and it's better you measure from XPS measurement or other techniques that maybe you know, and share me your comments if you have any idea about it, about measurement. But I choose it from the file. As you can see, the composition is showed here. Okay, I use OK. You can see the band gap, the first and second. I use a linear, which means the band gap is graded from 1.084 to 1.4. It is decreases linearly. Okay. Also, electron affinity, it's defined from the file. Let me show you. Sometimes it's better to see the initial and the final data. The initial affinity at x equals 0, it means 4.4267 electron volt, and the final 4.4717 electron volt. Okay. Also, we could use a grading for ND or NA, and we can use different let me show it again. Okay, we can just use a different interpolation law, which means different values of density. For example, logarithmic, you can see the logarithmic variation in shallow doping acceptor density. You can use OK, but I didn't change this value, and I use a constant value for the density of acceptor. Okay. I can use accept, and I can calculate single shot again, and I can see the variation when I choose a different grading concentration or doping for acceptor density. Okay, here we just talk about the grading in CZTSSe, and this is so simple, but it needs the data from valid and good references. For perovskite, for other material, also you can use the formula. Let me search about it. You can the common search is about bandgap graded in perovskite solar cell. Okay. As you can see, there are many papers that talk about these values. Let me show you. Also, we can choose a simulation. It seems these papers are not open because these are not open access. Okay, you can see the bandgap of uniform KFAMAPBI-BR perovskite absorber can be varied. We must read this paper. Also, this paper, we can just copy the we can just copy this link, and you can go to Sci-Hub. Maybe you know about the Sci-Hub to download the free paper. Okay, just paste the DOI here, and you can download the paper very easily. Okay, let me show you the function that this paper uses for simulation. Okay, as you can see, the bandgap is defined by the parabolic function. You can see the square of x and x, linear x, with the different coefficients. We can choose this value in the in our simulation, but consider this fact. In the SCAPS, let me close it. Consider this fact: in the material we have a composition that composition means the ratio of material, but you can see the grading for doping as the composition, and also you can use the grading with the thickness. It is very important which one of these method that you use for grading. But as you can see, in all of the properties, bandgap, electron affinity, dielectric, conduction, valence band, electron hole, thermal velocities and mobilities, the all dependence to composition of material. And the composition of material is related to the position in layer, which means when you use a composition of material to X layer, all of this basic is based on this file, okay, and you must use a correct file. Sometimes you can use a uniform, and you can set a values for that. It depends on your definition. Just you can remove these values and use any arbitrary values that you want it, but you must consider the sum of these two values must be equal to 1. Okay. And whenever we want to use a different material for the bandgap grading, we must consider the composition of material that depends to the thickness of that material, which is graded. And we can also use a constant value for some parameters that is not our concern. For example, dielectric permittivity and conduction and valence band, thermal velocities, mobilities, but the affinity and band gap, it's very important, and we must choose correct and right values to consider realistic simulations. Okay. We talk about this paper, that how we can choose this function into our example. It's better to show you SCAPS manual. I can also put the link of SCAPS download for you guys in the previous two-terminal tandem simulation Perovskite CZTSSe solar cell in the comments, because I'm not monetized yet, and YouTube didn't allow me to use a link for you, but in the comments and in the comments I provided the links for you. You can go and download it. Just search in the comments of previous tutorial. Okay, you can use Control F, use grading. Okay, you can see the table of contents. The general approach are here. You can see the functions are related to the composition that you want choose. You can see different function. Let me show you. As you can see, we have two constant. Maybe it's by dividing them by difference name. It's related to, let me use a paint. And we have 1.40, excuse me for that. .40 45 minus it's equal to, we can use a calculator. Excuse me, I'm not familiar with the Windows 11. I have some problem. I see. Okay, 1.54 minus 0.06, it's equal to 1.48. Okay, it's electron volt. Okay, we have a parabolic function. Let's see the SCAPS manual, which here we have linear and here we have parabolic, but it is better we use this is not our problem, because the squared composition in the it is here, it means this is not related to our problem, but it is similar to our problem. As we can see, we have PA and P0, but we have no linear part, and we have problem also with this function. Let me try this. Okay, we have linear here, parabolic, and okay, as you can see, we must to define our function, because there is no function similar as the function of this paper. Okay, how can we define this? We must use the from file, and from file we must define a file with the similar function, and after that import to the SCAPS software. Let me show you how can we import it. Excuse me for that. Okay, we can go to Excel. I have no Excel here. Maybe just give me a second. and we can use Excel. I will talk about Excel, inserting formula and doing some calculation in future tutorial, but I have Origin software, and also I will provide you tutorial about Origin, about the parts that maybe we need to use Origin and Excel. I will provide tutorial. Okay, I searched the Origin here. You can see Origin 2022, and you can write your function. I can use a variable x here, and I can just right click on the second column and set column values. Here I can input my equation. It's equal 1.48 plus 0.93x 0.93 multiplied by the x. It means a W column 1. I use W column 1 plus minus 0.21 squared x. I can use a bracket and use 2. Okay, I can choose OK, and you can see the code here. We must put the values of x here. You can search in the paper and see what x values are defined by these authors. Let me search on it. Maybe they use a function for x also, but yes, we must see that the x values as we can see, for uniform EG, the two numerically reproduce the experimental EQ and JV characteristics. 20% efficient perovskite solar cell with absorber reported into literature. It's better we use Ref 23, and the simulation was performed on assumption. First, the reproduction experimental on the variation of the EG from 1.55 to okay. As we can see, the values was changed from 1.55 to 1.61, and x from 0.08 to 0.14 in table 1. Let me see table 1. there is no x values, but we can see this. It is from here. Just we can change it, and let me choose 0.08. We can use set column values and click OK. Or let me, because sometimes the code you wrote, it is not updated, and you must write it again to see the update and see the function of your code. Okay, as you can see, when I input the 0.08, you can see 1.55 as the paper referred to this value. 1.55, yes, exactly the value the paper referred to this value. 1.61. Let me to try this value. 0.14, and let me cut it, use OK, and again let me set column values, Control V, and you can see the new values. Okay, 1.55 to 1.6. Let me see the value here. 1.61. it is nearly, because we have 1.68 and just approximated to 1.61. it is nearly okay. Maybe SCAPS also use approximation for that, the values, these values. Okay, just this simply we can use the different x values. You can cut it and write it to another row, and use different values between two of them, and we must consider this fact that the values better to ascending or descending. We must consider this fact. We can use, for example, 0.9. we can use 1, also 11, 12, 13, 14. It is maybe enough for us. I can delete it. I just set column values. I can Control X, Control V. Okay, and you can see the X and EG values. Okay, by writing the related formula. Okay, it's better to find the exact values between the lower and upper boundary conditions. Some papers don't care about these problems, and just they talk about the upper and lower, and maybe some of them use a picture, and you can see the variation of the ratio of material, and you can extract the data from the picture, but we couldn't see any picture for the material ratio. Okay, I can copy them. I go to the SCAPS directory. Let me show you how we can do it. I go to program file, I go to SCAPS, and I go to grading. You can open any of this file that you want. For example, I can use this, and it's better to open it with the text as a text file. Open with, it's better. I can see any text file here. Let me search Notepad, and it's better pin to taskbar. Maybe it is in the apps. Let me it's better to create a shortcut for that. Text document. And also we can't. Let me access to this file. Open with, go to the desktop, go all files. Oh, maybe it does not allow us. I hope the Google help us. Oh, it is very weird. To find a version for your PC, check with the software. Publisher we can use as a, I don't know, this not allow us to open with the text, but you can use the text for opening that. We can use let me Windows I think it's better we open it with also with origin. Let me use file, open. We can go to local disk C, program files, or you can go to desktop and use excuse me, we must go to SCAPS, grading, it is weird. Let me do another work for that. We can do a trick for opening this file. Let me show you how we can trick. Just copy any file that you want. For example, this file I copy, I paste it here. I can. Okay. We must see the extension file. For this, I must go to folder option. Folder up. In the view, we must show the extension, and we must untick the hide extension for known files. And after that, you can see the GRD file. Also, by dragging this file to the notepad, you can see the value, or maybe
Oh my god! Wow!
maybe we could drag it into origin. Let me show you how. Why? This is very weird for me. Why? We can just finish. Okay, you can see the file, the x values and the y values, and you can just copy and paste your data. Let me copy and paste. Control C, and I can remove. This, as you can see, this values is related to composition with the x function, which means this example is for here, but we want to example for here, because let me, for example, EG. You can see bandgap versus composition, okay, in the parameters, as you can see with the blue color. But for the red color, you can see, for example, let me use this value. You can see composition versus the position in layer or thickness. Okay, in the red color, and we can common introduction. For the red color, we have composition versus thickness, and for blue color, it means the composition versus the parameters versus the composition. Okay, and let me try with EG. For example, EG here. Let me. Okay, you can see Y composition and EG. I can remove it. Y, it means X in this paper. Let me show you. Where is the paper? Let me. here. The X here, it's not the thickness. It means the ratio of material, Y in SCAPS, okay? Just consider this fact, okay? And I can copy my data, copy, Control C, and paste, Control V. I can use a file, save as. I must consider the extension of this file, e.g. psk.grd. Okay. And it's better we use this, we copy and paste this file into the basic directory of SCAPS in the grading files. I paste. At first, whenever you want to modify this file in this directory, the SCAPS doesn't allow you to save here at first. But whenever you save the file that you created, that you modified in another directory, you can copy and paste here. But you can't modify file in this directory, as the Windows security and also the SCAPS security program. Okay. I see EGPSK, and here I can go to the panel of bandgap. I can use from file. I can go to from file, set grading file, date modify. You can see EGPSK, and you can see the function that I provided. You can see color of last calculated gradient profile by green color, and it can be readable from 1.679 to 1.567. Why you can see different value? It is because of your grading. Okay, we must set true values and correct values, the grading, to see the correct values here, and also the thickness and other thing. Okay, I hope you understand this problem. If you have any question about the grading, I would be happy if you share me your comments, and also give me your opinion about this problem. Also, we can set interfaces. As you can see, the capture cross section for electron and holes, energetic distributions, and density, you can add it. And also in contact we have a metal work function and thermonic emission or surface recombination velocities. And also you can use flat band as ohmic contact, and also you can use optical properties by mirrors, or use a transmission solar glass, and you can do your simulations. Okay, I hope you enjoyed this video. Please like this video, subscribe my channel, and share your comments to me, and give me your opinions. Have a good time. Take care. Goodbye.